Okay, welcome back to question number 7. So a satellite is released into orbit from a rocket that accelerates in 2 stages. So we can tell that bit just in there in the graph, my pen wants to work, that'll be where that second part is coming from, where that acceleration is. During the first stage, the rocket accelerates for 180 seconds. The second stage of acceleration begins 200 seconds into the flight. The graph represents the first 60 seconds of the rocket's flight after its launch. That is 10 minutes. So the rocket releases the satellite as soon as it reaches its final constant velocity, which happens about here. Work out how long after its launch the rocket releases the satellite. So we've got 500 seconds, and if we divide that by 60, that gives us 8 point something, which means it's 8 minutes. 8 times by 60 is 480, and if we subtract that from the 500, it gives us the 20 seconds remaining. Okay, so that is part A. Okay, we go to part B. So at which of those 4 times does the rocket have the greatest acceleration? Circle your answer. So at 50, it's not bad, but at 150, we can see that the graph is much steeper. Sorry, as I just set this to background. So 150 is better than 50. Okay, at 250, this is not as steep as at 150, so 250 can't be our answer either. And then at 550, there's no acceleration at all because it's at that constant speed. So our answer is 150 seconds. Okay, part C. Work out an estimate for the acceleration 400 seconds into the rocket's flight. State the units for your answer. So I'm going to do the units first. Meters per second and then time. It's going to be meters per second or meters per second squared for that acceleration. Right, where did it say I wanted it from? 400 seconds. So we're going to need to draw a tangent to this. I don't feel confident doing this with freehand, so kind of want to get the line function out here, and that'll be where actually we can use a ruler. That is perfect, and that's what you'll be doing in your exam. You'll be using a ruler. Okay, we rotate it and we want to make a tangent at where 400 is. That looks pretty good. I'm going to draw that line all the way across. So we can see that line will just touch the graph at 400, roughly, there or thereabouts. I'm happy with that. So down here I've got a coordinate. I've got a coordinate of 110 to 0, so I'll use that. And then we've got one there as well. That is 600 to 8,200. I think each of these, yep, they go up in 200s. So we'll use that, and this is going to be up divided by across. It's gone up by 8,200, and then we're dividing it by 490. I haven't prepared this solution because you need to be able to draw the graph, and these graphs will be different. So this gives me 8200 divided by 490 will give me 16.73469388, which I will round to 16.7. Now the mark scheme, I've written down what it says on the mark scheme, it's relatively generous. It wants a value between 14.5 and 21. So as long as you've shown those stages of your work in finding the gradient, it should all be okay. Okay, the satellite for part D orbits Earth at a velocity equal to the final velocity shown on the graph. I'm going to go find that now. The final velocity is greater than 7,200, so I'm going to say it's 7,250. 7,250. Okay, each time the satellite orbits the Earth, it travels a distance of 48,350 kilometers. Estimate the time in minutes it takes the satellite to orbit the Earth once. So this is speed, distance, and time. We're looking for time, so it's going to be distance, 48350. Now that's in kilometers. If I add 3 more zeros on at the end, that turns it into meters for me, and then we divide it by 7250 seconds to get an answer which is meters per second. Sorry about my spelling of the word second, what I'm doing here. Right, 6668.965517 seconds. I'm not going to risk trying to spell that again. And then if we divide that by 60, it's going to give us our minutes, which is 111.149 minutes. So I'd put 111, and our mark scheme is going to accept 109.6 to 112. So my answer has just fallen in there. And that is a very useful 12 marks. So hopefully you've got all of that correct. And I'll see you at question number 8.